Hi, and welcome to my presentation of the HDDL Parser. As the name implies, this software is a sort of toolkit for parsing and analyzing HDDL files, which are used for hierarchical planning. In particular, our software is an implementation of this paper detecting AI planning modeling mistakes. We have pretty much taken every error declared and identified in that paper and implemented as a software that we can actually use and work with. As you can see, quite a large range of errors from basic syntax issues and deviations from the grammar is detected to more sophisticated semantic errors such as contradictory formulas in preconditions and effects and so on. We provide two binary executables for the software. One is the command line version, which you can manually interact with and pass your files. And the other one is the language server, which implements the LSP protocol and can be used programmatically in IDEs and other development environments. As a matter of fact, we provide a VS Code extension, which is publicly available in the marketplace under the name of HDDL Parser, which you can install, and once configured with this path of the server, it automatically gets triggered when an HDDL file like this is opened. As you can see, the first thing is that we have this syntax highlighting feature. So as you can see in here, the VS Code now recognizes HDDL as a valid programming language and provides basic syntax highlighting for the declared keywords and types and user predicates and so on. Beyond that, we provide a pretty extensive set of error detection. For example, considering this method M2, which was defined for this task of connect devices, if we change this parameter, let's say to D1, we immediately get an error that this type is inconsistent because this task required an object of type signal type, but something else was provided. And when we fix that, it quickly gets resolved. Other errors that we can detect is, for example, if we have this ordering and we by accident included something like this, which is again cyclic, we get an error that task ordering is cyclic, which is obviously prohibited in the language. And other things are, for example, if we skip methods and go to actions, let's say this connect 5 action, where we have this not pre-guard as a precondition, and if we add its complement in here, we instantly get an error that this action has contradictory preconditions. And this is quite important because such an action cannot be executed because its precondition will not be satisfied in the status space. Here are some of the basic things that you can expect from this tool. Again, a global type checking for every part of the code and a bunch of error detections and diagnostics. A more perhaps complex problem is the problem file itself, and that is because it is not self-contained. We need the declarations from the domain in order to actually provide meaningful diagnostics. But luckily, our tool provides a smart mechanism that searches for the domain for any opened problem file, and as such can figure out, for example, if you change this to this, then this type is not defined in the original domain file. We can get other types of errors. For example, if we have this isPlug direction and we add another parameter to it, we can see that we get an error that this is inconsistent with the arity that was defined in the original declaration. And once we resolve it, it goes away. So this is pretty much a very short demonstration of what the Visual Studio code extension is capable of. But we also have the command line version. So if we copy the path of this file and go to here, and type in HDDL analyzer for the command line tool. First of all, we can see the list of commands that are available. We have the verify, which is pretty much the same thing that I have shown, but on the command line, we have the metadata, which would give some useful information about this domain. As you can see, it classifies the hierarchy, whether in this case it is empty recursive, meaning that we have a task which after a sequence of decomposition as shown in here reaches itself again without introducing any additional tasks. The set of nullable tasks is basically those that can be reduced to empty, meaning that they can be deleted by empty methods, which in this domain we don't have any. And the rest are some statistics about the number of actions and compound tasks and methods. Another important capability that we have is the JSON serialization. So if we call the toJSON command, the tool both verifies the file and outputs a very structured JSON file that we can also export to a file rather than the standard IO. As you can see, we get a very detailed description of what the domain has and also the problem if needed, in a very structured manner that is nested and structured as a tree. So for example, if we open the original domain file, we can see that it has roughly 400 lines of code, but with additional structure, the JSON file is more than 5,000 lines of code, meaning that it is very well structured, and you basically don't need, and validated, and you also don't need to parse the file any longer if you're developing, let's say, a planner, because this tool not only provides the type checking and parsing for you, but also a more high-level representation of the underlying HDDL files, which you can then call inside your program, basically at no other cost. I hope that you have enjoyed this presentation, and if you have any feedback or questions, please feel free to reach us via the emails that are provided on the GitHub page, and thanks for watching.